All right. Hey, y'all. So let's do the last half of this quiz review so I can go to bed. Just kidding. Love y'all. I love you so much that I would do this. All right. With the same understanding of conservation of energy, at the top of the hill, the boulder still has 1,000 joules. But this time it goes through a loop-de-loop. And at the top of the loop, the potential energy becomes 400 joules. So at the top of the hill, it's 1,000 joules potential energy. And our kinetic energy is 0 because it's not moving. So, how do we find how much kinetic energy we have? Well, we have to know that this plus this has to equal 1,000 joules because that's what we have at the beginning. Right? So, how do you find out? 1,000 minus 400 is 600 joules because 400 plus 600 equals 1,000, which is what we need over here. Okay, next. Oh my. Dang. Let's see if we have any other. Okay, let's do this one first. When doing a chin-up, so I always draw it out. I always draw it out because I don't know anything about physics and we have to figure it out by drawing. So that's me. Oh. Oh. Let me be true to my pronouns. So, my mass is 42 kilograms. Our distance is 0.25 meters. Our time is 2 seconds. What is the power delivered by the student's biceps? Okay, so this is a 3-step problem. So if you did it in one go, there's something wrong. So if we're looking for power, we need to work backwards because there's a whole thing. You have to do like 3 different equations. So we're looking for power. Power equals work over time. We have time. We don't have work. So we need to find work. Work equals now I'm messing up my one-stop shop. So work equals force over the change of distance. Okay. Oh, good news. We have distance. We do not have the force. So when you think about what our weight is, that is just our normal force. Okay? So when it asks for the weight, mass times gravity, that is the same thing as the force for us. So then you have to do, oh my goodness, it's like so many steps. If you're tired, I'm tired. Then to find force, you have to do mass times gravity. Okay? So it's a whole thing, but we're going to figure it out. Now I need to erase it. Okay, step 1. Oops. Step 1, find the weight. So mass times gravity. So 42 times 9.8. Hey Siri, what's 42 times 9.8?
42 times 9.8 is 411.6.
Perfect. So then we go to step 2, where we find work. And work is force times change of distance. So 411.6 times our distance, 0.25. Hey Siri, what's 411.6 times 0.25?
411.6 times 0.25 is 102.9.
Perfect. So then, step 3, our final step, to find power, we have to do work over time. And we have time, remember? So we're going to divide our work by our time. Oh my goodness. By our time. Hey Siri, what's 102.9 divided by 2?
102.9 divided by 2 is 51.45.
51.45. Closest one to that is 51.5. Okay? And then